I want to see you dancing. Hello, people of YouTube. It is time for the three of us who are congregated here right now to get bored along with me as I talk some mundane stuff about a car. Today we have a Pajero Montero, or what you call a Shogun. It has a no crank and it has a history of overheating. So we have a very interesting diagnosis coming up today because after a few problems with overheating, it now has a no crank. It came here, it arrived here on a flatbed. So come along with me for some boring car stuff. Update, by the way, I have a new microphone. So nowadays, I don't sound like Schrodinger's cat. I'm going to push it because it's a no start. I'm going to push it. I'm going to push the car all the way back there. And then we're going to find out what the problem is with our engine and whether we still have signs of overheating. Right? Twende mbele tena. Twende. Haya, sasa ndio hiyo. Hiyo iwe funzo kwa watoto wote. Ukiambiwa usome na bidii usome. Kuja kufanya kitu kaa hiyo. So we want to see whether what sort of codes are stored in the ECU so that we have an idea, so that we don't find anything else foreign that may affect our delivery of power generation. We want to find out whether we have cooling system errors. It has quite a number of errors in different control modules, but let's go to the engine first. See what's happening. Read the codes. Read the codes. Alternator. So alternator, something to do with the alternator, the signal of the alternator. No cooling codes, no problem with the diesel system or anything. So we are starting to safely see a pattern where our problem might be more mechanical than electrical. So this is going to be a good old-fashioned mechanical diagnosis where we want to establish the integrity of the cooling system, whether they are leaking areas, leaking pipes, cylinder head gasket, etc., etc. So this car had developed frequent problems of stalling on the road. But when I listened to the client or the owner of the car, they said that they had these recurring problems of overheating, losing coolant. They don't know where coolant is dripping to. At one time, they had to replace a pipe. Supposedly, they replaced a coolant pipe that was leaking. But by then, the engine had already overheated. So they've changed the head gasket a couple of times, but the car is still overheating. So when I went to take the car, or I went to pick the car on Sunday, not on Sunday, sorry, when I went to pick the car yesterday, I had to top up probably 1.5 liters of coolant. So it is true that coolant was seeping through somewhere or getting lost somewhere. If you're great intellectual fraud, a GIF like me, you hear that the head gasket has been done, and subsequently after the very first time they changed the head gasket, the car developed power problems. It was massively underpowered. The owner of the car told me that power was never the same. He didn't feel like performance was was able to go back to where the car was before it overheated the first time. So if you're a GIF, again, you start to suspect compression, because a diesel system is fairly easy. You only need fuel and you only need fuel and pressure, because diesels are self-igniting. They don't have spark plugs. So once the pressure builds up and a bit of spray of diesel is injected into the cylinder, that is enough for a diesel engine to go boom. So again, you start suspecting compression issues. They've done the cooling part many times. So why did the power, change? Why did the performance drop? Why did the power go down? Why isn't the car performing as it used to? Compression, compression, compression. So what's the relation between compression and the cooling system of a car? So the head gasket, which is what they've done a couple of times, the head gasket sits between the cylinder head and the engine block. And the engine block is where your cylinders are. This is a 4-cylinder engine. So there are 4 cylinders, literally 4, depressions or whatever you want to call them in the engine block. So the head gasket, make sure it completely seals the surface between the cylinder head and the block. So if the head gasket is, bad, it will leak compression. It can leak, coolant. Coolant can go where it's not supposed to. Oil can go where it's not supposed to. And compression gets lost, because when the piston is pushing up, once there is a space, a very minute space in between the head gasket, or the head gasket is worn out, you get loss of compression. So your diesel engine will have problems starting, as this one is not starting, it's just a long crank. Or if the loss of compression is not, bad enough, you'll get less power from your engine, because anytime the piston is pushing up, compressed air, diesel, just before it goes boom, there's a small leak. The specifications for pressure are not being met inside the cylinder. So what we'll do, I'll use this compression gauge of mine, and we will access the environment of, the interior of the cylinder. We will access the interior of the cylinder through the glow plug hole. Remember, diesels don't have a spark plug, but they do have glow plugs. And I had one glow plug. Oh yeah. So these glow plugs are what they act like. These are gentrified iron box, because once it receives current, or a gentrified or a glorified electric cooker, because once it receives current, it glows red hot at the tip. The tip is just inside the cylinder, so it glows red hot. The temperatures, it raises the temperatures sufficiently enough for when you turn the key to try this, when you crank the car, the temperatures are already hot. When the diesel is sprayed, the explosion can happen much, much faster. That's the work of glow plugs. That's why diesel cars long time ago took too long to start. You get someone with a diesel car, they're turning the key, it's cranking, because the temperatures inside the cylinders were not coming up as quickly as desired. So glow plugs, they glow red hot inside the cylinder, so that when the diesel is sprayed, the engine can come alive in the shortest time possible. So these are glow plugs. I've taken the glow plug for cylinder 1 out. We want to see how much compression is in cylinder 1. And to do that, I'm going to attach, this is an adapter. It looks like a glow plug, but it's hollow. It ties, or it bolts where the glow plug bolts. And then I'm going to attach my gauge, as simple as that. This is going to go into the engine. So when I crank the car, I'm going to get the pressure reading on this gauge. And once we get the readings for all 4 cylinders, then if we have a drop in pressure, we will automatically confirm that the engine suffered heat stress and compression is escaping through the gasket. So straight away, I'm going to bolt this adapter on, get this gauge set somewhere that you can see, and then we crank the car and measure the pressure, the compression figures for all 4 cylinders. So let's do it. I've bolted in my adapter. This is where glow plug for cylinder number 1 lives, and this is glow plug number 2, which after taking the measurements for cylinder 1, we'll replace the glow plug on this cylinder, take out glow plug number 2, and use the adapter for cylinder number 2 as well, and subsequently 3 and 4. So the pressure gauge will just sit in the lock into the glow plug like that. So we will crank the car and we take our readings for pressures for cylinder number 1. The optimal, I don't have the exact compression figures for this engine, but its predecessor, which is the 4M40, anything between 330 to 420 psi is healthy for a diesel engine. So I'm going to look for numbers close to that, but once I make sure that my adapter is well seated on the cylinder head so that we stop losing. I can feel a bit of hissing sound, so we stop losing that compression so that we can take the correct measurement. So I've mended my sealing surface. My adapter is now seated well. Let's take the correct compression figure for cylinder 1, and then we do that for the rest of the other 3. Chapa. Wacha. That's under 200 psi. I'm trying to place the gauge where the camera can get without the glare of the light. Okay, that's just under 200 psi. That cylinder 1 has. I'm going to confirm the correct compression figures for the 4M41 engine Mitsubishi, but just under 200 psi is already worrying. But again, with the customer saying that the car lost power some time ago, this is one of the symptoms. So cylinder 1 just under 200 psi. We can call that 190 psi. So let's do that for cylinder 2, 3, 4. We leave the pressure here. Then unplug our gauge. Set the gauge aside. Then I unscrew my adapter, which is a task that can be handled by a clever man very shortly, but clearly I'm handicapped. So to do this, for me to access the glow plugs, I have to take out quite a bit of stuff. Like there are fuel lines from the common rail to each cylinder. There's also a big throttle housing and a throttle body right where my hands are. So it's not as straightforward. It takes a bit of time, but once you take out everything out of the way, it will enable you to access your glow plugs easily, very easily. Ladies and gentlemen, we already have a pretty good idea of why the car lost power and subsequently failed to start. So the results came out as 190 psi for cylinder 1, 170 psi for cylinder 2, 186 psi for cylinder 3, and 220 psi for cylinder 4. This compared to a minimum of 330 psi and a maximum of 420 psi means that the heat stress this engine underwent while it was overheating definitely ruined the cylinder head surface or the engine block surface or even the integrity of the cylinder head bolts. That's why we're losing compression. That's why this engine was never the same. That's the part where we've read the compression figures. It's a very nice one to talk about because it's an interesting one. This car, the owner had changed the cylinder head gasket barely a couple of weeks ago. And that was not the first time they changed the cylinder head gasket. Throughout the durations of the car developing overheating issues for some while. The most recent time they did the head gasket was barely 2 weeks ago. So it's fair to say that that cylinder head is brand new. So why would a cylinder head gasket fail in 2 weeks? The issue is not that direct, however, because I'll give you an example with this engine. I'll use this car as a very good example. This car is a Montero diesel, 4-cylinder diesel. It's a very big, I think 3,000 or 3,200cc diesel. And it's a Euro 5 spec. It was for the European market before it came here, so it's a Euro 5 spec. Of course, now I think we're in Euro 6. I don't know that it's a 7, but this is a Euro 5. And what a Euro 5 spec is, someone at the Global Hotting Commission will approach the European government and tell them, hey, we want cleaner air, and we don't want big diesels, we don't want big vehicles. In fact, nowadays it's even extreme. They say we don't want internal combustion engines. So, but the manufacturers, the car manufacturers as well, have lobbying power. So what happens? The Global Hotting Commission will approach the governments of Europe and tell them, then make the car manufacturers, build cars that are more efficient, that don't pollute the environment in a much in a fast time. So what Euro 5 spec is, or what Euro spec, or what Euro whatever is, Euro whatever 4, 3, 5 is regulations and expectations of what or how an engine should perform, how much smoke how much pollution is coming from the tailpipe. That's mainly the issue. So to achieve more efficient engines, cleaner engines, car manufacturers do a lot of stuff. And key among which recently has been, reducing the weight of the vehicles. If your vehicle is light, consumes less fuel. Again, if you're a great intellectual fraud, you know that. If your car weighs lighter, it consumes less fuel. So how do you make an engine weigh lighter? You move from the traditional heavy materials, the iron blocks, steel, and you start researching on materials that are lighter but have similar structural integrity with iron as a block. So, I'm not saying Pajero specifically, but ever since 2007, 8, 9, car manufacturers have been on this rat race of trying to squeeze out as much efficiency as possible from different components of engines. So what happens? The engine block, the cylinder head, nowadays they're all made of less dense. I don't want to say less dense, I'm not a scientist, but less dense or lighter metals, but which have, structural integrity. They're made, engine blocks nowadays and cylinder heads are made of probably aluminum composites. Basically metals that are lighter than iron, but can hold together under stress of compression, etc., etc., etc. So you change a cylinder head gasket on a modern car like this, things don't work. What is happening? Well, it's because of heat stress. These materials that are building engines nowadays, once they undergo a period of heat stress, i.e. overheating, when you lose your coolant and your car is overheating and the temperatures are too hot that the engine stalls. That moment where everything is too hot, you get warping or bending of surfaces, of cylinder head surfaces, of the block surface. So if you have a small depression or small warp or an ununiform mating surface between the block and the cylinder head, where the cylinder head gasket sits, if you have a slightly scoured or bent surface, then the cylinder head gasket will not sit correctly. So what will happen? There will be spaces where the compression will escape from. Remember, again, diesel engines, the compression figures are massive. It's hilarious. It's not hilarious, it's almost amazing. Your tire pressure, when you go to the petrol station and you want to have, tires in your air in your tires, the maximum you can do is 35 psi. But for a diesel engine, it's 10 times, 11 times that. So 400 psi, we're barely getting 200. So definitely, compression is getting lost, and that is what happened with this engine. You can have the engine cylinder head gasket changed 4,000 times, but 4,000 times you will go back to the same problem: overheating, loss of power, etc., etc. So what's the remedy? You can have the block surface, the cylinder head surface, and all the cylinder head components machined. You know, the proper machine shop, they can do that. They can resurface the block, they can resurface the cylinder head surface. But also, the tricky thing is, in our market here in Kenya, the cylinder head, for example, is a huge component, one of the major components of the engines, but it's made up of very many parts, hundreds of parts. So you can imagine when heat stress happens, it can affect literally hundreds of parts. So if a part maybe expands or warps or changes its structure because the environment was too hot, then it has to be sorted. If it was sitting in a small groove or an allowance, that groove or that allowance has to be inspected, machined, and taken back to manufacturer's spec level. Otherwise, if you don't do that to a cylinder head, you will achieve nothing. So there are three components: the cylinder head, the block, and the bolts that mate the cylinder head and the block together. Even those where you torque down your cylinder head to your block, even those are affected by heat stress. So your cylinder head might be okay, your block might be okay, you change your head gasket, but now as you try to torque the cylinder head onto the block, you're not getting a sealing surface. So what happens? Loss of compression, no engine, lack of power, or at the worst, a non-functioning engine like this. So if you're here, the best option would be to get a good used engine, because again, I have not been around much, but to to machine or to recondition this cylinder head to manufacturer's spec I've not seen that kind of stuff happening here. If you try to do that, of course people do some machining stuff, but if you try to do that without meticulously taking care of everything, of those components that I've mentioned, you will use a lot of money, have work that was done not very well. You reassemble your engine, you get an unfunctioning engine after spending a load of money. So your best bet would be you rush to industrial area, get a good used engine, replace your engine, you go back to having the original smooth and powerful car that you had. So lastly, that's the diagnosis part. We know that we are losing compression because of overheating issues, most likely at the surface between the cylinder head and the block. But to be safe, I'm going to do one last procedure. Because the car overheated, obviously, because of losing coolant, I'm going to pressure test the cooling system so that I see whether we have any leak right now. I know the car owner told me there was indeed some leaks. They sorted some pipes, they bought some pipes, replaced. The leaks subdued, but there were also instances where they didn't know where the coolant was escaping from. But you'd go for a trip, and then you'd find the radiator is not full. Try to find a leak, they couldn't find. How is that? Again, I suspect because the cylinder head gasket separates oil, coolant, and compression. If it is wrong, the coolant can seep into the cylinders, then it gets combusted, blown out of the exhaust pipe. You may not realize, or you may not know because you will not find a leak in the engine bay, but you'll be asking yourself, where is my coolant going? I'm topping up coolant, going to doing probably 100 kilometers. The car is giving you a warning that coolant is low. That is what was happening. Whenever they didn't find a common leak, the coolant was most probably, and I can say that with confidence, the coolant was seeping into the cylinders, getting combusted, thrown out through the exhaust tailpipe. So let's pressure test the cooling system so that if I find a leak, I add that onto the diagnosis report and tell the client you need to do this and this and that so that we can solve the problem finally, solve it for the final time so we can have the. Let's pressure test the cooling system and then our diagnosis will be done. I've actually just remembered something. Another way to know that your compression is leaking onto your cooling system is actually taking the radiator cap off, try cranking the car. If there is excessive, bubbling or excessive eruptions of the coolant like a volcano, then you start to suspect compression. You can imagine 400 psi coming into the coolant system. It will push the coolant and eject it to the nearest place possible. So if I crank this car and coolant is shooting out like a volcano, I'll start suspecting that my compression is leaking into the cooling system because of the gasket issues or the block or the cylinder head issues. So I'm going to fill this with coolant, crank it, and you will see if it indeed shoots, then at least I'll earn my bread and butter for today because I'll know what I'm talking about. Let's do that, and then we see whether the compression will leak into the radiator. Then you can imagine. Chapa. Roger. So we've definitely seen some bubbles, but the tricky thing about using that method is it's not as accurate as using a compression gauge. Why? Because it is not abnormal for coolant to bubble in the radiator system because the water pump could be bleeding out air, and also the water, even if there was no air, the water pump is still spinning. So there's a chance that it will create, what can I call it? A tremor. You can create tremor through the cooling system. Hence, you can have slight bubbling. Now, depending on the RPM of the engine, if you raise the RPM, the water pump will spin faster. It will throw water out of the radiator, and you are most likely to get confused and say, I have leaking compression. But that's not it's not an accurate method. Always try and make sure a compression gauge is used to check the health of your, compression. If you're not getting the correct figures, you're definitely getting leaking compression. So I'm going to pressure test the cooling system itself. We find a leak. So I feel it. So I don't know whether we have pressure in our reservoir. Yes, we do. So I'm going to add a bit of pressure in the cooling system. Don't add too much because you risk blowing out the cooling system pipes. It's not holding pressure as well because my connecting point here is leaking, but it's holding sufficient pressure for me to peruse through the engine bay. The water pump is somewhere below here. I'm going to look at the pipes, the water pump below here, the thermostat, and any pipes. If I find any leak, then I'll know that even if we do some procedures on this car, if we don't solve that leak, we'll most likely have another overheating issue. What do you know? I found this wet area at the bottom of the vehicle, radiator on the bottom side, but it could be overflowing water from the radiator cap. So I'll try to investigate whether the leak increases with the increase in pressure, or if it doesn't increase, then the radiator will have to come out and be physically examined. That is a masterclass on how you buy a new engine because of cooling issues. I've not found any foreign or unusual happenings on the cooling system after pressure testing it. It looks like what the customer said checks in. They say there was a leak and they fixed it. I've not found any leak, but unfortunately they did so very late after the damage had been done. So there's no other remedy for this car. We'll just be diagnosing the issue. If and when we get to do the fix, I'll also try put something together for the three of you at home. But that's it. That's a masterclass on how you buy an engine from overheating issues. So until next time, I'll see you guys. Enjoy your time.